Hello guys, welcome to IB360. In this video, we are going to tackle one of the most fundamental portion of mechanics, that is free force diagram. So if you understand this concept thoroughly, you will encounter no further problems in mechanics. That is my guarantee. So let's just start. So forces can be broadly classified into two categories. First is our contact forces and next is our non-contact forces. So in order to form the free force diagrams, we need to know all the facts about contact forces and non-contact forces. So what are contact forces? So the forces that are exerted by two surfaces in contact, as simple as that. When two surfaces are in contact, they will exert what you call as contact forces. Okay, so in order to take an example, suppose I have a bottle over here. Okay, so I can say that the bottle is actually sitting on the ground, right? The bottle is actually sitting on the ground. So what I can say is that from this figure, that the lowermost portion of the bottle, suppose this is the lowermost portion of the bottle, above this lowermost portion is the entire bottle. Okay, so that means the lowermost portion of the bottle, okay, is in contact with the uppermost surface of the ground, right? Suppose this is the ground. When this is the ground and this is the uppermost surface, just a second. So this is the uppermost surface, right? So I can argue that the lowermost surface of the bottle is in contact with the uppermost surface of the ground. Okay, let's just name it as S1 and S2, right? So over here, as these surfaces are in contact with each other, right, they will exert what you known as contact forces. So let's just see how these contact forces will act. Okay, so first of all, there is a surface 1. So there is a surface S1, okay, which is the lowermost portion of the bottle, and second of all, there is a surface S2. Okay, surface S2, that is the uppermost portion of the ground. Okay, so that means surface 1 will exert a force towards surface 2 and let the value of that force be N1. Why is surface 1 exerting a force towards surface 2? Why? Because see, the two surfaces are in contact, right? And when two surfaces are in contact, they will exert forces on each other, right? So that means surface 1 will exert a force towards surface 2 and the value of that force will be N1. Okay, so let me just represent this force. So over here, this will be our force, that is N1. Similarly, what will happen is that by Newton's third law of motion, okay, every force has an equal and opposite reaction, right? So since surface 1 is exerting a force towards surface 2, surface 2 will also exert the same force but in the opposite direction, right? So that means surface 2 will exert a force on surface 1, okay, the value of that force will be N1 by Newton's third law of motion. Okay, so that means over here there will be N1 force. Okay, so in this way we will be dealing with the contact forces. Okay, so contact forces will be produced by two surfaces in contact. Okay, and we'll just draw this column and see the forces. Okay, we'll take this up later in examples. Okay, so now let's just go to our non-contact forces. So what is non-contact force? As the name suggests, which acts on an object without coming physically in contact with it, right? So what do you mean by this? So let me elaborate. Suppose there is a free falling lady. Okay, the lady is going on a dive, okay, from an airplane. Okay, so as you know that the weight of the lady is always mg, right, and that mg weight is always acting downwards, right? But this mg force is produced by the earth, right? This mg force is produced by the earth, right? So see that the earth, suppose this is the earth, okay, see that the earth is not in contact with the woman that is falling, right? But it still exerts a force mg on that woman downwards, right? So that means the earth and the woman are not in contact, but still they are exerting a force, okay, on the woman, right? So that means this force is our non-contact force. So this is our non-contact forces. Okay, so that means non-contact forces doesn't need two surfaces to act. It can act far apart without being in contact. Okay, similarly, see over here, suppose I have a magnet over here. Suppose this is the magnet and these are the nails. Okay, so when I bring the magnet close to the nails, not in contact with them, okay, just close to the nails, what will happen? The nails will jump from the ground towards the magnet, right? If the magnet is strong, right? So that means what? The magnet is not in contact with the nails, but the nails is still jumping towards the magnet, right? So that means the magnet is exerting a force. Suppose the value of the force is F on the nails, right? Towards the magnet, right? So that means the magnet is coming in contact with the nails, but still exerting a force, right? So that means the force exerted by the nails by the magnet is also a non-contact force. So this force F is also a non-contact force. So I hope you got the gist. Okay, so let's just go to our main thing now. So how to make a free force diagram? Okay, so first of all you have to isolate all the bodies. In order to elaborate, let me just take an example. Suppose I have a mass m that is sitting on the ground. Okay, so first of all I have to isolate the bodies. In order to isolate the bodies, we need to know which are the bodies. Okay, what do you mean by a body? Okay, so over here the bodies will be this mass m and the ground. Okay, this mass m and the ground will be our body. Okay, just a second. Okay, so that means if I just isolate the body, that means I'll draw the mass m first. First of all I'll draw the mass m and then I'll draw the ground. I just isolated the bodies, right? Isolated the bodies means just draw the bodies freely. Okay, so now we have completed our first step. So the next step comes to underline the surfaces in contact. So you have to be very careful in this one. Okay, see that the lowermost surface of the mass m, suppose I call this surface as S1, is in contact with the uppermost surface of the ground, right? Okay, so that means S1 and S2 are in contact. Okay, are any is there any more surfaces you can see that are in contact? No, obviously, right? There is only two surfaces in contact, S1 and S2. Why they are in contact? Because the mass m is sitting on the ground, right? They must be in contact. Okay, so now I just followed the two steps. Now let's just see the third step and the fourth step. So the third step is to analyze the contact forces and the non-contact forces. So over here, so let me just draw the figure first. So what we did, we just isolated the two bodies m and the ground, right? And what did we do? And we identify also which surfaces are in contact. So surfaces, the surface S1 and the surface S2 are in contact, right? So now we have to identify the contact forces and the non-contact forces. Okay, so now for identification of the contact forces or the representation of the contact forces, what we'll do is that we'll write that surface 1, okay, and surface 2. Surface 2. So since surface 1 is in contact with surface 2, what will happen? Surface 1 will exert a force towards surface 2 and the value of that force will be N1. Why is it exerting a force towards surface 2? Because they are in contact, and and when they are in contact they will exert forces on each other, right? So that means this will be our N1, right? So over here this will be our N1. So similarly, by Newton's third law of motion, surface 2 will also exert as the same force but in the opposite direction, right? Equal and opposite forces. So that means surface 2 will exert the same force N1 but in the opposite direction, right? So over here the value of that force will be how much? N1 exerted by surface 2 on surface 1. Okay, let me just write it over here. You will write that over here N1. Okay, I hope you got this part. Now we have to identify the non-contact forces. Okay, so the non-contact forces will be very good. The weight of the body, right, downwards, which always acts downward, mg. Okay, so we have followed step 3. So let's just see what is step 4. We have to draw a neat diagram. Okay, so if I just draw a neat diagram of the individual bodies, okay, so that means this is mass m. Over here upwards the force is n1, downwards the force is how much, mg, and this is our ground, this is our ground, and downwards the force will be how much, n1. So this is our free force diagram. Okay, I hope you got this. This is a pretty basic example. So let's just take one more example to boost up your clarifications. Okay, so over here suppose I have this m1 and m2, okay, and they are sitting on the ground. So first of all, step 1, yeah, what was step 1? Very good. Step 1 was to isolate all the bodies. Over here the bodies will be how, which m1, m2 and the ground, right? Over here this will be the bodies. Okay, so that means first of all isolate. So over here this is m1, then there is our m2, and lastly there will be our ground. So now we have successfully isolated the body. So congrats, you have successfully completed step 1. Okay, so now what was step 2? We have to identify the surfaces that are in contact, right? So that means, see, m1 is sitting on top of m2, so I can argue you that the lowermost surface of m1, suppose I call the surface as s1, is in contact with the uppermost layer of the, or the surface of m2, s2. Why surfaces 1 and 2 are in contact? Because the mass m1 is sitting on top of mass m2, obviously, right? So s1 and s2 are in contact first. Okay, we have identified this. Okay, also we can say that the lowermost section of m2, the lowermost surface of m2, that is surface s3, is in contact with the uppermost surface of the ground. Can I also say that? Yes, I can say that. Why? Because m2 is sitting on the ground, right? So that means s3 and s4 will be in contact, right? So that means s3 and s4 are also in contact. So we have successfully identified the surfaces in contact. Congratulations, we have completed step 2. Okay, so that means surface 1 and surface 2 are in contact. Similarly, surface 3 and surface 4 are in contact. Okay, so now we have to identify the contact forces, okay, and the non-contact forces. Okay, so that means surface 1, okay, surface 1, let's just go to this side, surface 1 and there is surface 2. So make a column. Okay, always you will make a column like this, surface 1 and surface 2. So what will happen is that, what will happen? So surface 1 will exert a force towards surface 2, right? And the value of that force will be n1. While will surface 1 exert a force towards surface 2? Because they are in contact. Okay, so that means over here the value of that force will be, okay, so let's just mark it with black. So over here the value of that force will be how much? n1. Similarly, what will happen? By Newton's third law of motion, surface 2 will also exert a force on surface 1, equal and opposite, and the value of that force will be n1. Very good. So that means over here our force will be how much? n1. Okay, similarly what will happen is that surface 2 and surface 3 are also in contact, right? So similarly what will happen is that, not surface 2, my apology, surface 3 and surface 4. Okay, so these two surfaces, right, surface 3 and surface 4, surface 3 and surface 4 are also in contact. So what will happen? Surface 3 will exert a force towards surface 4, right? Suppose the value of that force will be n2. Why I am taking n2? Because n1 is taken, right? Why surface 3 exerts a force on surface 4? Because they are in contact. Okay, so that means and over here this will be our how much, this will be our N2. So in the similar way, surface 4 will also exert a force on surface 3 equal and opposite by Newton's third law of motion. The value of the force will be how much, N2. So that means over here N2, right. So we have successfully completed the identification of the contact forces. So now we just need to identify the non-contact forces. Okay, so non-contact forces will be what? Yeah, it will be the weight of the body, right. So that means for M1 it will be how much, M1g downwards, and for M2 it will be how much, M2g downwards. Okay, so I hope you got this part 3 also, right. So we just proceed with the step 4. What is the step 4? Just draw a neat figure. You have completed all the steps successfully. We have to just draw a neat figure. So that means over here this is M1, over here this will be our how much, yeah, this will be our N1, this will be our M1g downwards. This is the free force diagram, of M1. Okay, for M2 what will be the free force diagram? We have already completed this. Okay, M2, now downwards will be how much, N1, upward will be how much, N2, and downwards will be again M2g. So this is the free force diagram of M2. Okay, and what will be the free force diagram of the ground? So if this is the ground, the free force diagram of the ground will be how much, N2 downwards. So this is the free force diagram of ground. Okay, so we have successfully completed the free force diagram of this figure. Okay, so I hope you like this video. So let's just take a few seconds for ourselves. Okay, so we'll be posting these videos regularly. Okay, and we'll be covering the entire syllabus of IB for you guys. Okay, we are the first channel up till now to do this, so please do subscribe, and if you have any doubts just feel free to comment in the comment section. We'll see your doubt and we'll post a video about it. So thank you very much. Do subscribe. Take care.